Recording mode. Okay, good morning, everyone. In the last session, we had discussed about the market basket model. So we are discussing about this paragraph, which is taken from this paper. And in this paragraph, we have discussed about the market-based basket model, and which is consist of various item set. And we need to find out the frequent item set from the market basket model so that we can get a better view of what is customer behavior for the data set and what are the different approach we can apply to improve the revenue of the business. Now, in this today's session, we'll discuss about the a priori algorithm. A priori algorithm is basically used for the finding out the frequent data set. So a priori is an algorithm for frequent item set mining and association rule learning over transactional databases. So a priori is basically using the association rule learning on the transactional databases. So we have already discussed about the association rule. So what is association rule? Let us briefly discuss about it. Association rule learning is a rule-based machine learning method for discovering interesting relationship between variables in a large data bases. No. So in a priori algorithm, we identifying the frequent individual items in the database and extending them to the larger and larger item set as long as those items appear sufficiently often in the database. So what is happening here, if you can see that we have gone through one example. So let me open the a whiteboard in the from Google Drive. So is it visible? Whiteboard is visible to everyone. Is it visible to everyone?
Yes, sir.
Okay. So basically, we have taken a item set here. In that we have discussed about the milk bread, milk chocolate, some common frequent items which are being bought by the customer. So if we'll apply some logic here, we'll count the different occurrence of the item set in the pattern where we are counting the single item set, then we are counting the dual item set, then we are counting the triplet. So what we are trying to do, we are trying to find out a frequent pattern here. So what happened when you are counting the single item within an item set, you can find out that that is of not so much meaningful for the uh, data mining because if you find out that certain item has more uh, selling compared to other item, so you can increase the inventory of those items. But here what we are trying to do here, we are trying to find out the dual or triplet item set where if a customer is buying item A, so we want to find out that what is the possibility of buying the item B. If a customer is buying a item A and B, then what is the possibility of buying the item C? So actually, we can do it by taking the more item set together and trying to find out their frequent pattern or occurrence pattern within the item set, the whole item set or the whole data set. So same thing is applicable in a priori algorithm. So what we are trying to do here, we are identifying the frequent indivisible items in the database and extending them to the larger and larger item set. So first we'll find out the frequent item in the database. So as you can see that here we have find the frequent item set in our given data set, that is a milk, bread, and so on. And what we are trying to do here, we are trying to find the those frequency of item set in a larger and larger data set. So what we're doing is we are trying to find them in a larger and larger item set. So that is done in the a priori algorithm. It was proposed by Agrawal and Srikanth in 1994, and it is designed to operate on database containing transactions. For example, collection of items bought by a customer or details of a website fragmentation or IP addresses. So if you have a data set which is having information what the customer has bought on a certain duration. So based on that data set, you can apply the priori algorithm to find out the most trending item set or most frequent item set that is being bought by the customer. Now, let us take an example. So this is our example database where the item set are 1, 2, 3, 4, 1 to 4, 1, 2, 2, 3, 4, 2, 3, 3, 4, and 2, 4. So here one can represent your milk, two can represent your bread, three can represent your butter, four can represent your jam or chocolate. So there are different item set that has been taken here. So let us assume that these are the item set being bought by the customer on a certain duration. Now we'll apply the a priori algorithm on this data set. Now we'll assume the support threshold equal to 3. Now just assume it that support threshold is equal to 3. We'll discuss how to calculate the support threshold, but right now for the concern of simplicity, we just assume that a support threshold equal to 3. So when we are talking about the support, it is the equal to 3. Means we are considering those items set which is having support greater than or equal to 3. If item set is having support threshold less than or equal to less than 3, then we are not going to consider that. So an item set is frequent if it appears in at least 3 transactions of the database. If an item set is frequent if it appears at least 3 transactions in the database. So you can also take the support 2 or one is not very much concerned because every item if they that is in a data set database, then definitely it can be bought by one time. So every item has a one support, so you can't take the one, but you can take 2, 3, 4, and 5 depends on your problem. So when we are taking the support threshold 3, we are just making sure that any item set which have occurrence of more than 3 times, that will be counted as a frequent item set. Otherwise, it will not be considered as a frequent item set. Now, the first step of a priori algorithm, count of the number of occurrence of item. Now we'll count the occurrence of the item. So this is our item set 1, 2, 3, 4, 1, 2, 4, 1, 2, 1, 2, 2, 3, 4, 2, 3, 3, 4, and 2, 4. Now we have taken the single item and we are counting the occurrence of it. So now let us count it. So if you are counting the occurrence of 1, then it has been appeared here, here, 1, 2, 3, and so on. So there are items that item 1 has appearance of 3 times. So we just write the 1, 3. Just forget the support here. It is only the number of occurrence of an item. Then we count the number of occurrence of item 2. So if you count the 2, then it is being appeared in first, second, third, fourth, fifth, sixth. So 2 has been appeared 6 times. Now third is being appeared 4 times. So you can count here 1, 2, 3, 4. And now 4 has been appeared 5 times. So you can count it 1, 2, 3, 4, 5. So now in this table, you can find the item and their number of occurrence within the data set. Now, let us call it a support of that particular item. So we'll just assign these value, these number of occurrence, which has been retrieved from the given data set, and we'll count this number of occurrence and we'll assign it as a support of item. So now item one has a support 3, item 2 has a support 6, item 3 has a support 4, item 4 has a support 5. Now, if you can find out that we have already assumed support threshold equal to 3. So what it means that if item is having greater than or equal to support 3, then we'll take that item as a frequent item. Otherwise, we'll discard that item. So here, the one support of one item one is greater than 3, and support of item 2 is greater than 6, support of item 3 is greater than 4, support of item 5, 4 is greater than 5. So all the item here having a support greater than or equal to 3. So we'll consider all these item as a frequent. So all the item set of size 1 have support at least C. So they are all frequent. Now, this is the first step a priori. So again, a priori says that identifying the frequent individual item in the database and extending them to larger item set. Now, we'll perform the same operation for the two items at a time. We have performed this operation for one item. Now we'll perform this operation for two items at a time. Now, so next step I priority. So now we'll take the item two times. So we two item at a time. So suppose we have taken the item 1 comma 2. So now we'll go this item set, and if you can see that when we are taking the occurrence of 1 comma 2, it has been occurred one time, two time, three time. So 1 comma 2 has the occurrence of three time. Same three here, 1 comma 3 has occurrence of one time. Let me copy it in a Jamboard so that we can get a better idea about it. Now is it visible? Okay. So earlier we have count the item set having a single occurrence. Now what we'll do here, we'll count the item set having a support of two times. So just let us count it here. So you can see here that 1 comma 2, is it visible, guys? Jamboard is visible to everyone. Jamboard is visible to everyone. Okay, okay. So if I will count the two item occurrence at a time, so you can find out that 1 comma 2 has occurrence 1, 2, 3. So we are just putting the support 3. Now the second frequent item set, two item set at a one time can be 2 comma 3 or 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, 3 comma 4. So there are all the possible set of items up to the length of 2 has been listed here. Now we are counting the occurrence of them. So now the next set of item is a 1 comma 3. So 1 comma 3 has only one occurrence. There are no other occurrence of 1 comma 3. So we just write 1. Now we'll go for 1 comma 4. So 1 comma 4 has a 2 occurrence. So we just write the 2. 2 comma 3 has a 1 occurrence, 2 occurrence, 3 occurrence. So we just write 3. 2 comma 4 has a 4 occurrence, 1, 2, 3, 4. So we just write here 4. 3 comma 4 has a 3 occurrence. So we just write 3 here. 1, 2, 3. So we just written 3 here. Okay. Now, in the next of February, we have generated a list of all pairs of frequent item 2 times. Okay, and we are trying to find out their number of occurrence, and we'll take it as a support. So here you can see the support has a values which can also be less than 1, and support has a value which is greater than 3 also. So we just count those support because we have assumed support threshold equal to 3. So we just count the support that is greater than or equal to 3. So we take 1 comma 2 as a frequent item. We'll discard 1 comma 3 as a frequent item. We'll discard 1 comma 4 as a frequent item set because it has support threshold less than 3. We take 2 comma 3 as a frequent item set because it has a support greater than 3. Now we'll take another set 2 comma 4. It has a support 4 comma. And we also take 3 comma 4 because it has a support 3 which is greater than or equal to 3. So these items set 3 comma 4, 2 comma 4, 2 comma 3 and 1 comma t are called frequent item set. Now guys, next question will be that what happens if I will take 4 items at a time. So suppose we have taken item support. So what can be the item? So please do it as an exercise. You can use the chat box and you can also edit here. I have made this complete jam board as editable, so you can edit here. One moment. Okay, so we have to find out the triplet item set where we are taking 3 items at a time. So anyone can take this Jamboard and just write the item set 3 items at a time. What are the possible list of item set 3 items at a time? Please do it. Or you can also use the chat box and provide your response in the chat box. Am I audible to everyone? We are just trying to find out items 4 at a, or you can also call it sorry, 3 at a time. We can call it a 3 at a time. So one moment. Triplet. We are trying to find out the triplet. Just write the answer in the chat box. What is the possibility list of triplets? Okay, I'm asking on a student who can respond. Srey, am I audible? Srey, please write the first item set, first triplet. Srey, am I audible? Sakshi Jaiswal, please. You can also edit on the Jamboard as well as you can use the chat box. Just response, provide your response. Sakshi Jaiswal. Yes, beta. Please provide the response. Ravi, you can all access the Jamboard. Try to access it. Is it accessible to everyone? Is it editable? Aditya? Yes. Yes, Sakshi, please. I want to do this exercise so that I can be sure that your concentration is in the session and you are giving your proper attention to the class. It should not be the situation where I am just delivering the lecture and you are just uh, access the session and do not giving your proper attention. Just write the triplet at a time. One response. Okay, it is view only. Okay, you can use the chat box. Let me change the now. Now is it editable? Just write the triplet at a time. Okay, other Sakshi is trying to access the jam, and till then other student can use the chat box and write the triplet at a time. Everyone, please provide your response. Amina, Aditya, Anurag, Ariman, everyone, Kavita, please provide your response in the chat box. If you are able to access jam, please provide the response in the jam also. I am waiting for a response. Just provide the list of triplet. Am I audible to everyone? Raj, you can use the chat box. Okay. Mohammed has responses. Let me copy the response in the uh, chat box. So these were the response from Mohammed. So he has responded with the three triplet 1 comma 2 comma 3, 1 comma 2 comma 4, 1 comma 3 comma 4. Is there any other possible triplet? 2 3 comma 4. It is not possible. 2 3 comma 4. That is one more triplet possible. Okay, there are more response. So Mohammed has again responses 1 2 3 1 2 4 1 3 4 2 3 4 2 1 3. Is it same? Mohammed 2 1 3 is same to 1 2 3 and 2 4 1 is same to 1 2 4. So these will not be the unique item set. So there are four item set 1 comma 2 comma 3 1 comma 2 comma 4 1 comma 3 comma 4 2 3 comma 4. So let me edit it. Saki has response good, and there is a one left 1 2 3 1 2 4 1 3 4. So 1 3 4. Now what is the occurrence of 1 3 4? One time. So guys, we have created a triplet, and we have also counted their support 1 1 2 1. But earlier you can see that in our problem we have assumed support threshold equal to 3. So we have assume one moment assume support threshold equal to 3. So what it what is it representing? What this triplet is representing here? what these triplets are representing here. All item set here is having a less support threshold less than 3. So they will not be considered as a frequent item set. Okay. Now, so when we are taking a next step of a priori algorithm and list of triples for of the frequent item set, so we are having no support item set having a support greater than 2. So no frequent triplet and 2 comma 3 comma is a below minimum threshold. You can consider that 2 comma 3 comma 4 having a higher possibility to count as a frequent item set. But other item set having a less than required threshold. No. So the final conclusion of your problem is the frequent sets of item in the database is 1 comma 2, 2 comma 3, 3 comma 4, 3 comma 4, and the highest requirement of the item set is 2 comma 4, which is having a support of more than 4. Okay. So is there any problem to understand this a priori algorithm? Is there any issues? Everyone, is there any issue to understand the problem? Is it okay? Please respond in the chat box. Okay. So now let us move further. So a priori algorithm has some limitation. These limitations are candidate generate large number of subset. The algorithm attempt to load up the candidate set as many as possible. So you will get a large number of subset and you have to deal with it. So it will create two problems. One is computing resources problem because you have a limited resources, and again a storage problem because you're having a limited main memory. So this algorithm is not very favorable for to work on a very large data set. So algorithm scan the database too many times and which reduce the overall performance also. It assumes that database is permanent in the memory, but that is not a case because you can see that when we are applying the priori algorithm, we'll assume that these whole item set, that is list of items say 1 comma 2 comma 3 to up to the 2 comma 4, that should be not be changed until we'll find the frequent item set. If it is being changed, then the whole the step that we have taken till that time will of no use. So we will assume that this will be permanent, but that is not the case with the a priori algorithm because whenever we are creating a database, that database is changing frequently. So that is one limitation of a priori algorithm. So now this is a pseudocode of a priori algorithm. I have taken this pseudocode from Wikipedia. So just go through this pseudocode, and if you are having any difficulty to understand the pseudocode, let me know. Okay, so that will be your assignment. Go through this pseudocode. If you have any problem to understand, then let me know. We'll discuss about it, and I will leave it with you. Okay, so let us move further. So there are few things we have discussed earlier. One was them is a support. So now we'll discuss about what is support. So there are three significant components of the a priori algorithm. They are support, confidence, and lift. Now we'll see what is support, what is confidence, and what is lift. So support. Support is the division of the number of transactions containing that item by the total number of transactions. So let us go toward Jamboard. So what is support here? It says support is number of transactions divided by a total number of transactions. So if I want to calculate the support of item 1, so how can we do that? Okay, so it will says that total number of occurrence involving age one. So we'll count where the transaction is involving one. One. So one, two, three. So one has been occurred three times divided total number of transactions. So there are total number of transactions are 1, 2, 3, 4, 5, 6, 7. So that is the support of 1. Same way we can calculate the support of item set 2, and that will be number of transactions involving 2. So number of transactions involving 2 are 1, 2, 3, 4, 5, 6, and total number of transactions are 7. So by this way, we can calculate the support of any transaction. So again, we'll go to the definition. Support is the division of number of transactions containing that item K, if you are referring that particular item as K, by the total number of transactions. So support K equal to transaction involving K division by total number of transactions. Support is the default popularity of any item. So if you are calculating the support by calculating the support, you can find out that if I will calculate the support of each and every item, let us calculate the support of T. So it will be 1, 2, 3, 4, 4 by 7. So if I will calculate the support of each and every item, so you can find out that the higher support of 2, which is a 6 by 7 of almost 80%. So you can find out that the most popular item is a 2. So suppose 2 is a bread here and 1 is a milk and so on. If you assume that, then 2 has a more popularity compared to other items. Say. So when we are getting a support of any item, then it is also represent the default popularity of any item. So suppose you will get a question where you're having a data set and you have to find out the most popular item within the data set. So you can calculate the support of that particular item. Okay. Now, second one is a confidence. So confidence is dividing the number of transactions that include giving item K by the total number of transactions. Okay. So now, when we are calculating the confidence, we are just calculating the item set having dependency on each other. Now, how can we calculate the confidence? Let right here. So confidence of item set, suppose 1 and 2. So we are calculating the confidence of 1 comma 2. So again, the same formula applied. The transaction involving 1 comma 2. So 1 comma 2 has been occurred in first, second, to third. So there are 3 transactions which is having the 1 comma 2, and the total number of transactions we have already calculated, that is 7. Same way we can calculate confidence of item set. Let us calculate 1 comma 3. So it can be 3. What can be the confidence here? If I will calculate 1 comma 3 has had the occurrence one time, and we just write 1 comma 7. Okay. By this way, we can calculate the confidence of each item. Okay. So we have calculated the confidence of set 1 comma 2, that is equal to 3. 3 is the number of transactions involving 1 comma 2. So we have already calculated the support of 1 comma 2, that is the number of transactions involving 1 comma 2, set that is 3, and total number of transactions is 7. So that will be 3 by 7. Same thing, if you are calculating the confidence of 1 comma 3, and that is a transaction involving 1 comma 3 is 1, and total number of transactions is 7. So we just calculate 1 comma 7. Same way we calculate all the support, the confidence of each and every item. So you can find out 2 comma 4 will have a higher confidence level because it is having a more number of occurrence transaction involving it. Now back to the slide. So confidence is dividing the number of transactions include the given item set, suppose item set K and T, by the total number of transactions. So confidence equal to transaction involving both K and T divided by total number of transaction involving K. So here jam is representing by K, or you can represent anything here. So here we are representing K. Okay. So confidence. Let me correct that because we have gone through some. We have to revise it. Here 7 will not be here because we are calculating the confidence of 1 comma 2. So what we do here, we'll calculate the confidence of transaction involving both 1 comma 2 and divided by transaction involving 1. So 1 is involved by 3 years, so it will be 3 by 3. And again, if you are calculating the 1 comma 3, then again it will be divided by 3. So division will be by the total number of transactions involving K. Here jam is represented by the K. Confidence is the likelihood that customer bought both K and T. Okay. So when we are have want to find out what is the likelihood of any item when the customer is buying K and T, then we can calculate using the confidence. Now the next term is lift, and lift is the increase in the ratio of scale K when you sell T. So suppose you are selling an item set item T, then what is the sell ratio of K when you are selling the T? So we can calculate the using the lift. So lift is calculating like this: confidence of T and K respect to T. If you are calculating the confidence T where with respect to K and divided by support of T. So what you are getting, that will be lift. So what the lift is representing here, likelihood of a customer buying both K and T together. Okay. So guys, these are some terminology of a priori algorithm. In the next session, we'll go with this problem and we're trying to find out what is the support, confidence, and lift of these example. Okay. So that's all for today's session. And if you have any question and doubt, you can use the chat box, and as well as you can unmute your mic and you can communicate. Okay. Thank you for joining the session.